It's clear tonight and it's springtime, so let's have a look at a beautiful globular cluster in Canes Venatici, M3 or Messier 3. I'll show you how to find M3, and then I'll show you what it looks like in a pair of binoculars, a 102mm refractor, an 8-inch Schmidt-Cassegrain, and a 10-inch Dobsonian. Hello. Hello and welcome to the program Sula's Big Adventures with me, Sula. This episode is about M3 or Messier 3 globular cluster in Canes Venatici. Globular clusters are a type of star cluster. Star clusters are just a collection of stars that are gravitationally attracted to each other, and globular clusters are spherical or ball-shaped and tight, and they're ancient. And M3 is a globular cluster. And it's ancient. It's 11.4 billion years old, almost as old as our universe. And it contains over 500,000 stars, and it's just spectacular in a telescope. You can see it with binoculars, but it'll just appear as a fuzzy patch. And I'll show you that after the sun goes down. And you can see it in small telescopes, but with a bigger telescope, it's really spectacular. So you start off with your lowest magnification and center it, and then you want to increase your magnification as much as possible, and then it'll just really shine, and you'll be able to identify individual stars. And if your telescope is large enough, you'll be able to identify stars all the way to the core of the globular cluster. The globular cluster is 34,000 light years away, and its magnitude 6.2, so it's actually even visible to the naked eye, but only from a very dark place under transparent skies and with no moon. To find M3, you start at Arcturus, the brightest star in Boötes. And Arcturus is easy to find because you go to the handle of the Big Dipper and you arc to Arcturus, and it's kind of orangey colored. And M3 is in between Arcturus and another fairly bright star, a magnitude 3 star, Cor Caroli, which is a beautiful double star in Canes Venatici. And I'll show you how to find that. And M3 is almost exactly in between those two stars. It's about maybe 12 degrees from Arcturus and about 13 degrees from Cor Caroli, which is the alpha star of Canes Venatici. So, as soon as it gets dark, I'll show you how to find M3, and then we'll have a look at it. Bye-bye, Jupiter. It's about to fade away into superior conjunction. Bye-bye. Bye-bye, Pons Brooks also. To find M3, face north and look for the Big Dipper. In springtime, the bowl will be pouring out its contents. There's the bowl, and there's the handle. There's the Big Dipper. And the last star in the handle of the Big Dipper is Alcade. Or if you start from Alcade, you'll arc to Arcturus, that bright star, the fourth brightest star in the night sky, and the brightest star in Boötes, the herdsman. It kind of looks like a kite on its side. You're going to start at Arcturus and head towards this star right here, Cor Caroli, the brightest star in Canes Venatici, the hunting dogs. And M3 is about halfway between Arcturus and Cor Caroli. It's out right there. I easily found it with a pair of 10 by 42 binoculars. By 42 binoculars has a 6-degree field of view. So from Arcturus, if I just went 2 binocular fields, that put me right on it. And it looks like a big fuzzy ball in binoculars. Wow. Pretty neat. Pretty neat. Well, I have M3 and the 102 millimeter refractor. And I started with 36 millimeter eyepiece. That gave me about 20 times magnification. And it just looked like a fuzzy patch. And now I have in a 10 millimeter eyepiece, which gives me about 71 times magnification. And I can just make out some stars on the exterior. Not very well, though. It's still pretty much a fuzzy patch. When Charles Messier discovered M3 in 1764, he thought it was a nebula because he couldn't resolve any stars. And it was only when William Herschel looked at it in one of his giant reflector telescopes that he was able to resolve individual stars, and that's when he realized that it was a star cluster, a globular cluster, and not a nebula. But Charles Messier was observing with a very similar instrument. He observed with a 100 millimeter refractor at Hotel de Cluny in Paris. So I don't know why he couldn't resolve stars, but you should be able to resolve stars with high enough magnification with a 4-inch or 100 millimeter telescope. But if you have a bigger telescope, 6 inches, 8 inches, 10 inches, you'll be able to resolve individual stars down to the core of M3, and it's just spectacular. Okay, I finished my sketch through the 102 millimeter refractor. There are very few stars in the star field, and that's the reason why I told you to look halfway between Cor Caroli and Arcturus, because there aren't any bright stars nearby to help you star hop, and honestly, that's the easiest way, and you should be able to find it. It's a bright object, and you'll be able to see it in your finder scope if you use a magnifying finder scope, and that will help you. But I was able to easily find it, and I finished my sketch with the 102 millimeter refractor. Now let's look with the 8-inch Schmidt-Cassegrain. Oh, wow. Oh, wow. That is beautiful. Beautiful. Oh, beautiful cluster. Now I'm looking at M3 through an 8-inch telescope. It's a Schmidt-Cassegrain, but that's not nearly as important a type of telescope as the fact that it's 8-inch aperture, because the bigger aperture will allow you to resolve more stars in a globular cluster. So it will have a lot more detail in a bigger aperture telescope. And it does on this one. And have a 10 millimeter eyepiece in, and this has a 2032 millimeter focal length, so that's allowing me to get a lot bigger magnification. That's 200 times magnification, and that helps you resolve the stars as well. So the bigger aperture, higher magnification, that will allow you to resolve more than globular clusters, and M3 is no exception. It's spectacular. Can't wait to look at it in the 10-inch Dobsonian. Let me tell you a little bit about this observation site, because the other big factor on what you can see in the night sky, aside from aperture, is sky conditions, the transparency, and the seeing if you're trying to see double stars, but mostly transparency for deep sky objects. And that is there smoke, or there clouds, is there haze, humidity, and is there light pollution, the number one factor. But for star clusters, it's doesn't impact it as much as things like galaxies, which you just can't see if it's light polluted most of the time. But globular clusters and star clusters, they're affected by light pollution. And where I am now, it's Bortle 4 for now. I've been coming here for years as a state park in Northern California, and I've been coming here for 25 years for meteor showers and stargazing, and it's pretty good at Bortle 4, but I also took a sky quality measurement. That is a device that will actually measure the quality of the sky, and it was 20.5, which is okay. You can't see the Milky Way here. Not right now because it's not going to rise until after midnight, late April. But the sky quality will also impact how well you can see things. But the biggest factor for a globular cluster is going to be your aperture and how much you can magnify and the transparency. So there's no moon, and so that's good. And so I could see a lot at 200 times magnification. It's spectacular, but it's going to look even better with this 9mm. It's very easy to find. Almost as easy as eyes are. And so if you go see M3 in a very dark sky site, Bortle 1 or 2, you may be able to see it with your naked eye, but you'll definitely be able to see it with binoculars, even in probably your backyard, because it's a fairly bright object. And if you have a larger aperture telescope, you'll be able to resolve stars, and it's just stunning, beautiful, beautiful object. And I encourage you to study it, and then you'll see more. And be sure to dark adapt your eyes first. So that's it for now. Hope you enjoyed it. I'll see y'all soon. Until then, get outside and enjoy the night sky. Dark skies forever. Sula, signing off.